Well, hello everyone. Welcome to the part 3 of the instrument flying series. In the last video, we discussed about the interpretation of instruments. We basically briefly went through it. And as we move along with this series, you'll get the deeper and better understanding of how to interpret those instruments and how to use that data to execute the maneuvers that we want to. So in this video, we'll be starting with the first maneuver, which is referred to as radial interception. So first of all, we must know what radials are. Radials are nothing but, if this is my stations, these are just these are lines emitting out of stations, which have the name of the magnetic heading that it specifically represents from the station. So if this is a line, if I draw from the station, if it has a magnetic heading of 045, this is the line of 045 or a radial of 045. If my aircraft is anywhere on this line, I'll call this that my aircraft is on radial 045. And this is actually helps us to understand where the aircraft is with respect to the station. Intercepting a radial basically means that if I have a specific radial, let's just say I have a radial of 045 from the station. And if I want to go out on this specific radial on a straight line, what I'll have to do is I'll have to intercept a radial of 045. And this is what we call as radial interception. Radial interception can be of basically of 4 types. First is inbound to inbound, outbound to outbound, outbound to inbound, and inbound to outbound. Whenever we are doing a maneuver in instrument flying, 3 things that are very important to know is where am I? Second thing that you must know is where I want to go, and third is where I need to turn. By inbound and outbound, what I mean is whenever your aircraft is coming to the station, we'll call it that the aircraft is coming inbound, and wherever an aircraft is going out from a station, we'll call it that aircraft is going outbound. So another thing to know about the course. The course of an aircraft is not radial. Whenever we are coming inbound, the course that we are following will always be opposite to that of the radial. That means if I'm coming inbound on 09 or 0, if I'm coming inbound on radial of 09 or 0, so I am on radial 09 or 0, but the course which I am following will be 270. But due to winds, let's just say if I'm having winds to the right, from the right, that is from starboard side, if I'm having winds, I'm giving wind correction to my right. So my aircraft is something like this. So my heading might be 280. I'm following a course of 270 on a radial of 09 or 0. Similarly, if I were, let's just say, take an example. Let's take another example of radial. Let's just say I'm taking 300. This is the radial 300. On radial 300, if I am going outbound, my radial would be 300 and my course will also be the same because I'm following this course, that is 300. And due to winds, my heading might change. Let's just say I'm having winds from the port side. My aircraft's nose will be pointing towards the wind for giving the wind correction and to follow the same course. So my heading can be 290. My heading will be 290. My course will be 300 and my radial will be 300 as well. Let's take the first example, which is your outbound to outbound. Let's just take an example. If this is a radial of 030, if my aircraft is going on radial of 030 outbound, my radial is 030, my course will be same as I'm going out, it will be same as the radial, which is 030. Okay, now I want to go to radial 050. Now, as from these 3 things, we know that where am I? I'm at radial 030. Where I want to go, 050. Now, where I need to turn? I need to turn right. But now I know that I need to turn right. But how much do I turn? And now you know that there is something, as we are on a specific radial where we want to go and where we need to turn right. But this third, which important thing, which is how much do I turn, which heading do I need to turn to, is the one thing that you must become masters of. As if you are able to calculate the perfect heading to which to turn to intercept a specific radial, then boom, there is nothing which can stop you for radial interception. So there are basically 4 methods through which you can derive the heading that you need to turn to intercept a specific radial. The first method will be your distance based, your capping method. Third is difference between radials multiplied by 3, where max will be 70 degrees, you cannot exceed 70 degrees, and the fourth one is always 45-degree method. Let's just try to derive the headings through all these four different methods so that you will know which one to follow and which one will be the best for you. If we go towards the first distance-based method, it says that if you are between 0 to 5 nautical miles from the station, you apply a correction of 30 degrees. If you are 5 to 10 miles from the station, you apply a correction of 45 degrees. If you are greater than 10 miles, then you apply a correction of 60 degrees. Now, you know that why this correction is increasing, because as we go far and far away from the station, the distance between these radials keeps on increasing as well, as these are lines which are emitting out. So as the further you grow from the station, the further these radials are from each other. So let's just say in this example, I was 0 to, if I was about 7 nautical miles from the station, then this 7 nautical miles from outbound to, in case of outbound to outbound, if I need to turn right, I am at this category, which is 5 to 10. That means I need to apply a correction of 45 degrees. So I will be adding, because I'm going to my right, my heading will always increase, because when you go to your left, your heading always decreases. If you turn to right, your heading will always increase. So this is telling me that if I need to turn right, I need to add a correction of 45 degrees. In which leg you will be adding? You will be adding in the leg that you actually want to intercept. So basically what do I mean is, the 45-degree correction you will be applying in the desired course that you want to follow. So the desired course that I will be following next will be 050. So in case of 050, I will be applying a correction of 45 degrees, which will give me a heading to follow of 95 degrees. So basically if I follow a heading of 95, I'll get to intercept my radial. I get a desired heading that I need to follow, and 095 it is. Let's just look at the another method. The second method that we'll discuss is the difference between radial multiplied by 3. Let's just discuss first that. So in this, maximum correction that you can apply will be 70 degrees. You will never go beyond 70 degrees ka correction to the heading that you actually want to follow later when you will be on that specific radial, the course which you will be following. Now, in this case, what you will do is, as I'm on 030 and I want to follow 050, right? So the difference between the radials coming 20 degrees, I multiplied by 3, I get 60 degrees. So I need to apply 60-degree correction to my desired course which I want to follow. The desired course which I want to follow is 50 degrees. I apply a 60-degree correction, I get a heading of 110 degrees. So 110 degrees is the thing that I will be going into. I'll just set my heading to 110 and then I'll just drag that heading until my needle becomes alive and I intercept that specific radial. So what is needle becoming alive? How do we intercept a specific radial is something which we'll be doing when we'll be actually executing in that simulator. We'll get to understand that how we are basically intercepting a specific radial. And in this, in which case you need to add and in which case you need to subtract, I have a just short table and a smart way to memorize it. We'll just discuss it and then we'll be good to go. But first we'll discuss how to calculate that in all four methods we'll see. So the third method is always 45 degree. This is simple. You don't need to make any calculation. Just apply a 45-degree correction to your desired course. Yeah, desired course is 50 degree. I'll add 45. The heading I get is 95 degree. So this is one of the simpler methods that there are. But this is actually not very precise, as when you are very close to the station. As we know that the radials are basically lines which are emitting out of the station. So the further we go from a station, the distance between two radials is constantly increasing. So the reason why there is distance-based method is that it is actually more precise, and I basically use it more frequently because it gives you a desired distance in which you apply a certain correction to get the interception of a specific radial, so that you are not applying excessive or less corrections based on your distance. The fourth is the capping method. Capping method is very simple. Let's just say if I draw this scenario that we have here on an HSI. HSI shows my heading here. My heading will be, let's just say, nil wind conditions. In nil wind conditions, my heading is 030. I am following. My RMI needle always showing my radial will be something like this. I will be on radial 030. If 030 is here, 210 will be here. If 210 is here, I will have 120 here, 120 is here, I'll add 300 here. The green line which I need to set, I will set it to 050. My course will show that I am actually left. That is, my track is to my right. So the deviation needle will show be somewhere here. And it will be showing that you are 20 degrees to your left. So it will be maximum deflection will be there. So capping method tells you that what you need to do, you just see your deviation needle and whatever heading is coming in front of this, you set your heading bug to that, you note that heading and you follow it and you will intercept your radial. So what it is telling you is that if this heading was somewhere around 100 degrees, you see this, whichever heading is coming in front of this deviation needle that is deflected, 100 degrees, okay, I'll follow a heading of 100 to intercept this radial. So you directly get the heading by seeing the deviation needle when you have set the course which you need to follow. So this there are no calculations required and it is considered far easier to follow. Now we know that how to calculate a specific heading. In all the examples all the simulators that we'll be doing in this series, we'll be going with the distance-based method. We'll be following that to intercept a specific radial. So let's just say we saw outbound to outbound. Let's just take a case of inbound to inbound. Inbound, I was coming on a radial of 300 and I want to come on a radial of 280 inbound. I was somewhere here and I want to come here. Okay. Now what I know is that if I'm on radial 300, if I'm coming inbound, my course will be 120 and my desired course will be 100. How do you get your course? You just take the opposite value, that is, in a clockwise opposite value. You subtract 180 or you add 180 to get your desired reversal, right? So now, there is simple plus 2 minus 2 method as well, but it has some exceptions. So basically, 1508, if 150 I want to calculate the reciprocal of 150. What will I do? Because this is less than 2, I will add 2 here and I will subtract 2 from this digit. So I will get 330. So opposite of 150 will become 330. Now let's just say if I had 240. This is 2 or 3. If this is 2 or 3, then you subtract 2. If this is 1 or 0, you add 2. Right? So the first is said 240. I'll subtract 2 here, I'll add 2 here. It will be 060. 060 will be my reversal. So this is an easier way to calculate the reciprocal of a certain heading. Now, but this has some exceptions as well. Let's just say 190. You have 190 mein I'll subtract 2 and I'll add 2 here. So this gives me 0 ho gaya, this become 11 and this is like this. So in just whenever there is a digit 9, you just need to know, okay, if I subtract 180 from this, I will get 1010. Coming back to the case that we were on radial 300 and wanted to intercept radial 280, right? So now from the distance base, let's just say I was 11 nautical miles. As I will be turning right, I will be adding 60 degree to my desired course. My desired course is 100. I will add 60 degrees. I'll get a heading of 160 to follow. So I will follow a heading of 160 to intercept my desired radial. Similarly, so in simpler cases which are outbound to outbound and inbound to inbound, these are simple. I was going out, now I'm again going out. If I'm coming in, I'm again going in. These are simple things. Simple things follow simple procedures. They do not disturb anything. If I'm going right, I will add. If I'm going left, I will subtract. Okay. But in case of inbound to outbound or outbound to inbound, this is actually reversed. On right you are adding, on left you are subtracting. If you are going inbound to outbound, you will be, in right case you will subtract and in case of left you will add. Third case, we take off inbound to outbound. Anything I draw, if I am tracking a radial of 180 inbound, I want to go outbound on a radial of 170. Okay. I was tracking it inbound something like this. Now I want to go outbound something like this. Okay. Now, because the next thing which I'm going outbound, my desired course or the final course will be 170. It will not be reciprocal. If my desired course is again inbound, I will have to reciprocate it, right? Because inbound mein course is always the reciprocal. So my desired course I know is 170. I set it to 170, my course now. Okay. Now I know कि 170 is my desired course. I am, let's just say I'm 8 nautical miles. So I know I'm 8 miles, I need to apply 45-degree ka correction. Okay. In this case, because I know I am on radial 180, I want to go 170, I need to turn to my right. And because I'm going inbound to outbound, in my case, I am going right, I will be subtracting. This is where the catch comes in. So my desired course is 170 degrees. I will be subtracting 45 degrees because I'm turning right. So this is why all the three things were important. Where am I? मैं कौन से रेडियल पे हूँ, where I want to go, मेरे को किस कोर्स को फॉलो करना है एंड में, and where I need to turn. Where I need to turn, if I know I need to turn right, I know inbound से inbound में I have to add, outbound से outbound में I have to add, inbound से outbound में I have to subtract, outbound से inbound में I have to subtract. So 125 degrees key heading if I follow, that is somewhere here. If I follow about 125 degrees, I will be able to intercept radial 170 outbound. Let's just take the next case, outbound to inbound. I was coming from, let's just say, take these radials, we haven't taken these, 230 and 215. Let's just make a little complex. Okay. So I was going outbound on 230 and I was 20 miles from the station. And I want to come inbound on radial of 215. Right. So now I'm 20 miles, I know I need to apply 60-degree ka correction. Now, because the next is my desired course, right? So the next course, the next radial which I want to intercept is inbound. I will have to reciprocate to get the course that I will be following. So 215 is the radial. The reciprocal of 215 will be 135. 035, correction. 035 degrees will be the course that we will need to follow. So our desired course we know 035 degrees. Correction I know 60 degrees. Now I know because it is outbound to inbound. If I am turning now 230, I am 215 is to my left. I know I will be turning left, so I'll be adding, right? Otherwise, अगर normal case होता तो left में subtract, right में add, because this is ulta case. We'll be left में adding. That is 35 में add. You will do this and you will get a heading of 0, 9 or 5. So you will be following a heading of 0, 9 or 5 degrees to intercept the radial 215 or the desired course 035. So this is how you basically calculate your heading. So the important things that you need to know is where you want to turn, to your left or your right. But to know where you want to turn, you need to know where you are and where you want to go. Once you know where to turn, you need to know which heading to follow. For which heading to follow, you need to know your desired course and you need to know your correction that you are applying. And based on the case, you add plus or minus. So inbound to inbound and outbound to outbound, towards turn to your right, you will be adding, and turn to your left, you will be subtracting. But in case of ulta, because I turn right, heading increases, I turn left, heading decreases. But if this was ulta case, which is outbound to outbound and inbound to outbound, turning right will give me negative and turning left will give me addition. So you just need to know your desired course, where you want to turn and where you want to turn. So you'll get whether you want to add or subtract to your heading or how much correction you need to make. And if you don't want to do all this, you can use capping method. Just enter the desired course in the instrument, the deviation needle, wherever it is pointing, follow that specific heading to follow the course. So now in the next part, the next subsequent video to this will be the video in which we'll be actually executing the radial interceptions, and we'll be discussing hat checks and T checks and introduction to that. And these initial videos will be something like this because you need to get the basics done, and once the basics are done, then the further videos or the complex maneuvers like holdings and DME arcs will be comparatively become easier for you once you get to know everything. So thank you for joining. This would be all from my side for today for Radial Interception. This is Animesh Sanyal signing off. Bye bye.